Hello, I am Amandine Delutz, Marketing Communications Manager at the company SEDI-ATI Fibres Optiques. Today, it is my pleasure to give this short talk about fiber optic assemblies dedicated to diffuse reflectance spectroscopy. But first, let me briefly introduce our company. SEDI-ATI is a French company whose origins date back to the 1950s. Today, we employ almost 50 people, half of whom are involved in on-site production and 12% in R&D and innovation. Our mission is to help you bring light into any environment, whatever your constraints are, whether the environment is simple to deal with or complex, and even harsh or extreme, meaning high vacuum or high pressure, cryogenic conditions or very high temperatures, but also radiations, corrosive or abrasive environments, just to name a few. In order to help you overcome your challenges, we have developed a strong expertise in fiber optic assemblies, allowing us to design a variety of passive fiber optic components dedicated to your specific applications. Among the solutions we propose, we offer fiber optic-based probes to perform spectroscopic measurements. There are so many things in the world that are invisible to the human eye. Using the properties of light, we can investigate the structures of organic and inorganic compounds. Spectroscopy is one of the only contactless and non-destructive methods to help us see, measure, analyze, characterize, identify, well, in other words, to gain information about a material. There is a plethora of applications for which spectroscopy can help. For instance, in the agricultural industry, spectroscopy can be used to monitor crop health and assess produce ripeness and quality. Other industries, such as the pharmaceutical industry, the food and beverage, or the chemical industry, use spectroscopy to perform industrial online process control. Spectroscopy is also used in astronomy. Using special equipment like a spectrograph or a spectroscope, astronomers can split light from space into a spectrum and examine its spectral lines to infer what compounds are emitted or absorbed. By the way, did you know that it was by using spectroscopy that the humankind discovered the first extrasolar planets? Or that the study of the spectral emission lines of distant galaxies led to the discovery that the universe is expanding rapidly and isotropically? Fascinating, isn't it? Well, because of the intrinsic properties of optical fibers, fiber optic-based probes are perfectly adapted to perform and enhance spectroscopic measurements. Besides, they allow to reduce the size of spectrometers as no more free space optics are needed. The principle of such fiber optic assemblies is quite simple. The light source emits an incident light that is guided by an optical fiber to illuminate a sample. Different phenomena can occur from the interaction between the photons and the atoms and molecules of the sample. The light can be backscattered by the object to be analyzed, either as it is or with a shifted wavelength. The reflected or emitted light is gathered back through the fiber optic probe, followed by redirection towards the detector or spectrometer. My challenge today is to give you a quick overview of 3 different technologies that SEDI-ATI offers to be used as fiber optic probes for spectroscopy. Of course, each solution features intrinsic properties and different advantages that have to be considered depending on the targeted application. Here is a focus on fiber optic bifurcated bundles. This is the most commonly used solution for spectroscopy. Fiber optical bundles usually consist of optical fibers in a round or linear configuration, combined in an end piece or in a SMA 905 connector to match the entrance lead of most spectrometers. This is a 100% customizable component. Fiber types, number of fibers, detection geometry, round, square, any shape, and configuration, mapping of the fibers, random or coherent. Everything is possible. Now, another solution. I would like to present to you a spatial fiber optic coupler. This is a 1x2 high directivity fiber optic multimode coupler in a round trip configuration. It is suited for optical metrology and sensing, where the dynamic range of the sensor is a key parameter. The unique manufacturing technology of this coupler is based on wavefront division. The main benefits of this technique, other than high directivity, are mode insensitivity and achromaticity. Here, the high directivity is a great advantage to minimize the light that can directly pass from the injection port to the output port. This way, a minimal mismatch between the input and the reflected signal is achieved. Also, this solution offers a much better spectral resolution than fiber optic bundles, since it is made of graded index 50 micrometer core fibers. The last solution I would like to introduce is a fiber optic multimode wavelength division multiplexer. So far, WDMs have been largely used in telecoms and data communications. Standard configurations are usually based on graded index fibers and optimized for telecom wavelengths. But there is a huge interest from the industry for sensing applications using WDMs at different wavelength ranges in the UV, in the visible, and in the infrared spectra, and using different types of fibers. This interest is motivated by the fact that the component enables to select key wavelengths of interest. This is made possible thanks to the deposition of a custom dichroic filter directly at the core of the component. The incident light that can pass through the dichroic filter is guided to the sample by the sample leg. The light that is either emitted or backscattered by the sample is gathered back through the same fiber. But only the wavelengths that can be reflected by the dichroic filter are redirected towards the detector. These unique properties make this component an ideal solution for fluorescence detection. This is an illustration of the combination between our WDM and an optical fiber that we have inserted into a hypodermic needle to perform some invasive analysis, for instance. Well, this is already over. So thank you very much for watching. Should you have any questions or need to learn more, please feel free to contact us. Our sales and applications experts will be happy to discuss how SEDI-ATI can add value to your research or topics. Have a nice day. Bye-bye.